अस्सलाम वालेकुम। आज हमारी जो क्लास है we will discuss about the some aspects of the absorption. And previous two classes we have taken the concept of drug absorption through membrane and also some theories from which we understand how the drug is absorbing from the one membrane, one area to another area. And today we will discuss the another concept of drug absorption, which is given us the concept of those drugs which are converted into their ionic forms. First of all, we will start first with the passive diffusion. That was our previous class topic. We discuss it, passive diffusion of non-ionic drugs, and other is ionic drugs. In case of non-ionic drugs, we have an idea and concept of the first law of diffusion. But when we discuss with the ionic drugs, we will read pH partition theory. This pH partition theory is actually based on the Henderson and Hazelberg equation. In our previous class, we detailed discussed with the Fick's law, and we assume that this Fick's law is actually the explanation of first order rate kinetics. Why it's first order rate kinetics? Because in the case of Fick's first law, we assume that rate of change of concentration with respect to time is directly proportional to the surface area, rate constant Km, and thickness of the length, and also the thickness of the membrane, and then the concentration gradient of the two mediums. This was our actual concept. This C2 is the actual concentration of GIT, and C1 is concentration in plasma. And we assume that the concentration of drug in the GIT is maximum, and due to the presence of this maximum concentration, drug will move from the higher concentration towards the lower concentration through the concentration gradient, which is the actual concept of our passive diffusion. Okay, by observing this, we have this concentration is maximum at the start and minimum in the plasma. As the concentration increasing in the plasma, but due to the maximum volume of the plasma and all the tissues, we have the negligible amount of drug here, and this concentration gradient will give us the huge difference. We will assume that whole concentration of GIT is much more as compared to concentration of plasma. We can also observe that when we give the drugs in its dose are in the milligram. 100 milligram nemsolite, 50 milligram sodium, potassium, and the dichloran and other. These are in milligrams. But when we estimate these concentration in plasma, they are in microgram per ml, in ppm. And so there is a large number of large amount of the differences between these two concentrations. We assume that this concentration is negligible, and the whole scenario is the This is the whole constant, and we will write it permeation constant, Pm, and then this is our concentration in GITE. This is equal to the rate of change of concentration. And this concept is actually concept of the first order rate kinetics. I have already told in my previous classes. It means we can solve this problem to justify the equation of the fixed first law of diffusion, which is the explanation of first order rate kinetics. Okay, now coming toward our another concept, that is for the ionic drugs, which is actually pH partition theory, which is we can say Henderson and Hazelbalch equation. This equation gives us some interrelationship of pH, pKa, and their log values. Log values of their ionic concentrations of the drug, and also the pH and pKa. These are the interrelationship which is called pH partition theory. And in case of pH partition theory, we will assume that there are the two basic types of the classes, weakly acidic and the weakly basic classes. Weakly acidic drugs gets ionized when they come towards their medium, and they absorb by the different ways, because we have already studied in the passive diffusion, there were the two basic concepts, transcellular and intracellular. And in case of transcellular means drug is moving from the cellular, and the intracellular means drug is moving from the between the cells, the spaces which are present in the between the different cellular bases. So ionic drugs will move not only by the transcellular, it will move from the intracellular base, and these are the basic concept of the ionic reactions. We will divide this pH partition theory into two main classes. For the pH partition theory for weakly acidic drug, and pH partition theory for the weakly basic drugs. pH partition concept for weakly acidic drugs, and another is weakly basic drugs. Okay, in this scenario, we will learn something about pH, pKa. pH means it's a negative logarithm of hydrogen ion concentration. And pKa is the negative logarithm of association rate constant. pKa, it's actually the time at which 50% of the drug is in ionized form and 50% of drug is not in unionized form. So we will write the pH and pKa, then we understand the concept of the these weakly acidic and weakly basic drugs. In case of weakly acidic drug, we will make some equations for the calculation of their values. First equation for the log. I will write this equation in 3 or 4 different ways. First way is log A over 1 minus A is equal to pH minus pKa. Okay, A we can say it A or alpha. It's actually ionization of the drug. A is the ionized form of the drug, and 1 minus A is unionized of the form of the drug. And in case of this, A is ionized and 1 minus A is unionized. Okay, can we take the anti-log? Yes. Then the formula is 1 minus A is equal to anti-log of pH minus pKa. Why we are studying this? We are studying this because drug gets converted into the ionized, and these ionization depends on the pH of our medium. Particularly when we take the drug orally, we have the different mediums in our whole GI tract. Alkaline environment in our oral cavity, acidic environment in our stomach, and then alkaline environment in our intestine, and so on. Alkaline environment means we have the variation in the pH in our GI tract. When we looking the variation, it means drug gets converted into their ions. And as we have the concept of the log D, in case of log D, we use the buffer solution as compared to the aqueous. Why we are using, we were using the buffer solution? Because we want to first ionize it and then want to convert it, check its log D values. Same in case with the, when drug is moving towards our GI tract, it will convert into two parts, particularly those drugs which should have been absorbed by their ionization concept, which should have to be absorbed by the intracellular penetration. Then we will assume that the drug has now two parts. One is its ionized part, another is non-ionized, unionized part. Unionized part is basically the actual nature of the drug, but when it comes toward in our body, it will convert into the different segments. Okay, what things which we should have to be remembered? We should have to be remembered the pKa value of the drugs. For example, if we are discussing about the salicylic acid, which is weakly acidic drug, its pKa value is 3. Okay, we have and so many examples of the pKa values, and we can check by looking the some. There is a table in Sunil Jambaker book where we have given the two different data of the weakly acidic and weakly basic drugs. Quinine, weakly basic drug, and pKa value is 8.4. We will discuss why we are discussing this pKa value. In case of weakly acidic drug, we have equation log A over 1 minus A is equal to pH minus pKa, and either log alpha 1 minus alpha is equal to pH minus pKa. And the same case with the, we can take the anti-log. This formula can also be write alpha over 1 minus alpha is equal to 10 power pH minus pKa. These are the three different ways to write this equation for the weakly acidic drug. I have used the same scenario, same words, but I am just modifying their values by taking the log, okay, by taking the anti-log. When we take the anti-log and log will be cancelled, and here will be the anti-log. Okay, if I apply that log base 10 and log base 10 and the log will be cancelled and log base 10 will be here and pH minus pKa. Remember, I am taking the difference of these pH minus pKa. This pH is pH of our medium. For example, I am discussing the pH of the stomach. Then I will assume that that pH is 1.2. And if I am discussing the pH of my alkaline area, intestine, 6.8, then I will write the pH 6.8 and pK value of the drug, solve this problem, and will get the values of the ionized and the unionized concentration. Okay, if the drug is in unionized form, then we will assume that having the maximum drug of the unionized form, then we will assume that the drug is absorbing from that area, because according to our concept, we have plenty of opportunity drug can be absorbed if it is in unionized form. So by using this theory, we can check at the particular sites of our body at what site where will be the maximum concentration of the drug is in ionized and where the maximum concentration of the drug is unionized. I can write also this formula in another way, but check by changing the another concept of the concentration of ionized over concentration of weakly acidic drug, and that will be equal to 10 raised to power pH minus pKa. Remember, I have just changed the words. Concentration of salt, ionized, and concentration of the pure, weakly acidic drug. Why I am writing it this way? Because when I go towards the weakly basic drug, I will change this formula. I can also, these are the 4 different ways to write the pH partition theory for the weakly acidic drug. Okay, we want to clear our concept. For example, we are discussing weakly acidic drug which is acetyl salicylic acid, aspirin. Okay, if we are aspirin and we have taken the value opportunity of this pH pKa value which is 3, and we are assuming that pH, the drug is present at that area where the pH of the medium is also 3. Okay, what will be happen? For example, we will put the value here because this equation seems like very simple. If I have pH value 1, or pH value 3, and pKa value 3, 3 minus 3 is 0. 10 raised to power 0 is 1. I will solve here. For example, this one, this is our concept. Ionized drug, my unionized drug is equal to 10 raised to power. Our pH of the medium is 3 and pK is also 3. Means 10 raised to power 0, which is 1. Ionized, 1 minus ionized. We get the cross multiplication, and ionize 1 into 1 minus A will be combined. A plus A is equal to 1. 2A is equal to 1. A is equal to 1.2, which is 0.5. Means 50%. If, now we are making the sentence. If we have same pH medium as the same pKa value of the drug, it assumes that concentration of the drug is 50% ionized and 50% unionized. If we have the same value of pH and pKa. Remember, pKa is actually the property of drug, therapeutic agent, and pH is the value of the medium which we are discussing, especially in the GI tract. If we are discussing the scenario where the particularly acetyl salicylic acid, because we are getting the example of acetyl salicylic acid in weakly acidic drug, it means pKa value is 3, okay, and we are assuming that that area where pH is 3, then we will calculate its ionized and unionized conditions. Drug is 50% ionized and 50% is unionized. Okay, now if we move that area, the drug moves, and in that area where the pH is 1 unit greater than the pKa, means the drug is present where we have the value of the pH is 4 and pK is 3. Then we'll write, okay, ionized, 1 minus ionized, unionized means, and 10 raised to power 4 pH of the body, 3 is the pKa value. Okay, we can solve it. We have the value of 10 raised to power 1 and 1 minus A, this will be 10. Okay, when we multiply this is ionized drug is equal to 10 into 1 minus unionized, and the values are 10 minus 10A. A will be combined, and that will be A plus 10A is equal to 10. 11A is equal to 10. A is equal to 10 by 11, which is 0.9. 0.99, because 10 divided by 11, 0, 99, okay, then 1, then 0, then 0, it's 90, sorry, 0.90. So, we will assume that 90% of drug is ionized. 90% of drug is in ionized form and 10% of drug is unionized form. So, there is a maximum chance of drug to be absorbed in ionic form in the case of acetyl salicylic acid, where if we discussing the ionization concept in that area, or we can assume that there is a minimum value of the unionized form of the drug, which is 10%. Okay, we can make another calculation. For example, we assume that pH is now 5 and pKa value is 3. What we are discussing? We are discussing about the 2-point differences of the drug. And in case of 2-point differences means pH of the body is the medium where the drug is present, is 5 and the pKa is 3. Then we will get the difference of the two. I can write here 5, okay, and the difference is 2, which is equal to 100, and this 100 will be this 100 and 100A, okay, 100 and 100A. I will solve from here. Okay, now it's 101. A is equal to 100. A is equal to 100 by 101. So 100 plus A is equal to 101. Okay, answer is 0.99. It means 99% drug is now in ionic form and only 1% of drug is present in non-ionic, anionic form. What we are discussing? We are discussing pH partition theory. Why we are studying the pH partition theory? Because we are discussing those drugs which are showing us the behavior of the ionization. In case of Fick's first law, we have discussed those drugs which give us the concept of the non-ionic drug absorption and from the paracellular. In case of intracellular, where the ionization will be involved, we will assume that there is some type of the two categories of the drug, either it's weakly acidic or the weakly basic. In case of weakly acidic and weakly basic, we will have to check their pKa value, association rate constant value, their negative log of the association rate constant, the time where the 50% of drug is in the ionized form, pKa. We will assume that the pKa values of the particular drug which is constant, and then we will compensate it compare with the values of the pH which are present in our body. In oral cavity, what will happen with the acetylsalicylic acid? In stomach, what will happen with the acetylsalicylic acid? In intestine, what will happen? We can check only by taking the two values of pKa of the drug and also the pH of the medium. Okay, then this is the increasing way. Okay, we can also assume that if the condition is the drug is present in that area where pKa value is greater and pH value is less. For example, in stomach. So in stomach pH is 1.2. Okay, well, we assume that pH is 2 and pK value of the acetylsalicylic acid is 3. Now it's a difference. It's a different scenario. We will use the same equation. For example, ionized form of the drug divided by unionized form of the drug, 10 raised to power. Now we are assuming that pH value is less and pK value is higher. So pH is 2 and pK is 3. Difference is 10 raised to power minus 1. 10 raised to power minus 1. This is actually 0.1. We can write it 0.1. Okay. Ionized over 1 minus ionized is equal to 0.1. This will be multiplied here. 0.1 minus 0.1A and this is A is equal to 0.1. Now plus 0.1A is equal to 0.1. And we will have the 1.1A is equal to 0.1. Okay, now we divide with the ionized drug. 0.1 divided by 1.1. Answer is 0.09%, 0.09, which is actually 9% drug is now ionized and 91% drug is in unionized. So we are discussing acetylsalicylic acid, aspirin, and aspirin in the acidic medium in the stomach give us maximum amount of its unionized form and having the maximum chance to be absorbed from the stomach. But due to the physiology of the stomach, which I will discuss in the later classes, when the stomach is not suitable for the sake of absorption. Mostly absorption area is our alkaline, our intestine, because there are present of the villi and the microvilli. So we will assume that there is a 9% of the ionized drug in case of stomach where the pH is 2. And how much concentration of the drug is unionized? It's almost 10%. 91.9%. It's 0.09 and it's 91%. 91% drug is now unionized. 1 minus A. 1 means 100. And we are assuming that, okay, it's 91% drug is in unionized form. Okay, we move another difference. We are getting the difference of 1. If we are getting the difference of 2, then what will happen? For example, pH of the medium stomach is highly acidic, which is 1. Okay, then our pK value of the drug is 3. What we will do? 1 minus 3. The formula is ionized drug divided by 1 minus ionized drug, 10 raised to power, okay, pH is 1 of the stomach and 3 is the pKa value, difference is minus 2, which is equal to 0.01. Now, the scenario is ionized 0.01 into 1 minus ionized, answer is 0.01 minus 0.01 ionized, and 1 plus 0.01 ionized equal to 0.01. Answer is 1.01 divided by 1.01. 0.01 divided by 0.01. Answer is 0.009, means only 0.9% drug is in ionized form, where we have less pH as compared to pKa. pK is greater. Now we will make a sentence. For example, first sentence, if pH and pKa are same, we will assume that drug is 50% ionized and 50% unionized, particularly for the weakly acidic drug. And when we have we can make a table. For example, pH and pKa, and then ionized form and its unionized form. For aspirin, okay, we can write. For example, pK is 3, which is constant, and pH is also 3. It's 50% ionized and 50% unionized. First sentence. Okay, if we have pH value 1 unit greater than pKa, if we have pH value 1 unit greater than pKa, then our drug is, mostly of our drug is in the form of unionized. Means it's, we have discussed it, for example, that was, when we are getting a difference of 1, we have already written here, 9% ionized and 91% unionized. Same case, if we have the difference of the 2, positive 2, means pH is 5 and pK is 3, then we have ionized concentration how much? That was? We can also calculate here once again. For example, we have the difference of the 2, and the difference of 2 was 100, and the formula was 100 divided by 101. That was 100 and 101 was 0.9. And same case, 0.9 means 90% of drug is ionized and 10% of drug is unionized. Okay, when we discuss the scenario of the difference of -1, we have the value of 0.9%. We will change this value. 91% ionized and 9% unionized. I guess it's somewhat difficult to learn now. First of all, we can make another. For example, we are discussing this 1 minus 3, where is when we have the 3 and here is 1, we can write 0.9% is ionized and 99.1% is unionized. It's okay? There is some difference we can check. For example, in case of 2 minus 3, answer is, for example, 0.1 divided by 1.1. What will be the answer? 0.1 divided by 1.1. 0.09. 0.09 means 9%. Okay, we'll write here 9% ionized and 91.9% is unionized, or 91% is unionized. There are some changes. Okay, when we discuss these values, for example, we have the difference of equal 50% ionization of the pKa and pH, and we have the difference of this. Then we will have the values of change of the value. We can also check here. Okay, we have the difference of 1. 1 means here is, for example, we have the 1, it's 10, and 10 means it will be 11, 10 by 11. What will the 10 by 11? 10 by 11 is 0.9, means 90% ionized. We should have to correct here, it's 90% and it's 10%. And when we have the difference of the 2, it's 100, and we have the 100 divided by 100, which is equal to 99, and this is 1%. Now it's okay. Means at the same level of the pH and pKa 50%. When we get the difference of 1, positive 1, the 90% drug is in ionized form and 10% is in unionized form. And we have the difference of the 2, positive 2, then the 99% is unionized form and 1% unionized. And we have the difference of the negative 1, means pH is 1 unit lesser than the pKa. Then we will assume that 9% of drug is present in the in ionized form and 91% in unionized form. Means here the pH drug can be maximum show its absorbance. And in case of difference of the 2, then we will assume that okay, the pH ionized formation is only 0.9% and unionized 99.1. It means if we have an empty stomach and we are getting the aspirin, empty stomach and having the pH 1 or 1.2, then it's assumed that maximum drug will be in unionized form. Aspirin will give us unionization in acidic environment. And the minimum absorption in will be occur because it's due to the anatomy of the stomach. But in case of, if we are taking the same concept of the ionization and we are assuming that unionized drug is available for the maximum absorption, then we can assume that at that stage aspirin have the maximum chance to be absorbed. But the drug is absorbing in the small intestine where the pH is 6.8, or the 6.8 or the 6. Now the difference of their pH and pK is 3. It means that if we are taking the difference of the 3, we have the maximum unionized formation. And these ionized formation are basically passing through the paracellular, intracellular spaces, and they are due to the concentration gradient and having the concept of the diffusion. Okay, now we can make the 3 sentences here. For example, if the drug have their maximum ionization, where the drug is maximum ionization, drug will be present maximum at that compartment. For example, drug is present maximum ionized form in that area, in the GA system. Then the maximum drug is present in the GA system, not present in the plasma. Okay, where the drug is present in unionized formation, it will be the lesser amount of the drug will be present at that area. Means there can be a chance to be absorbed of the drug. For example, in GA system, drug is in unionized form, and there is a chance to be absorbed by the diffusion, by the concentration gradient from one area to another area, one GA system towards the systemic circulation. This might be possible, and we can make a sentence if the drug, where the drug is in maximum unionized, it means its concentration in that area will be reduced because it will absorb to another compartment, and ionized drug will be show us the particular that compartment where it will be lie. Okay, these are all almost some story about the weakly acidic drug. We have at this table, we can check the values of the salicylic acid and then aspirin. I will assume that all of the students will take even 2 or 3 examples of the weakly acidic drug, search their pKa values, and then check their ionization and unionization at the different pH, at pH 4.5, pH 6.8 and pH 1.2 for the weakly acidic drug. Okay, now comes towards the weakly basic drugs. Okay, well, we will remain this table because we will compare it with the weakly acidic and weakly basic drug. Okay, pH, partition theory. For weakly basic drugs. In case of weakly basic drugs, we will assume that there is another formula which is log value of ionized over 1 minus ionized is pKa minus pH. Remember, this formula is little bit changed. In weakly acidic, that was pH minus pKa. Now we are discussing pKa minus pH because we are now discussing the weakly basic drugs. In case of weakly basic drugs, we assume that there is a difference between the pKa and pH, okay, and we can check its ionization and unionization conditions. We can also write this formula, anti-log of and log of A over 1 minus A is equal to log of pKa minus pH. We can cut this, and this ionized and divided by the unionized drug, concentration of ionized drug divided by the concentration of unionized drug is equal to log values of pKa minus pH. Okay, in the third way, ionized drug over 1 minus ionized drug will be equal to 10 raised to power pKa minus pH. Same formula which we have used in the weakly acidic drug, but now the words are now changed. We have changed from pH to the pK and pK to the pH. Remember, pH is the negative logarithm of hydrogen ion concentration, and pKa is the negative logarithm of association rate constant, the time at which the 50% of drug is in ionized form and 50% in unionized form. Okay, same case, we can also write another way, that equation is for the weakly basic drug. For example, the base divided by its salt. Remember, in case of acid, we write its salt divided by the acid, that was equal to the pH minus pKa. For weakly acidic. But in case of weakly basic, we have divided this base value, rate of concentration of base divided by its concentration of its salt is equal to pH minus pKa. Same scenario, but we have changed this. It means we can also change this scenario is ionized and unionized formation. We can also write this unionized divided by the ionized, then our values will be 10 power pH minus pKa, the value will be same. So we can write this pH partition theory equation, Henderson-Hazelbalch equations, by 4 or 5 ways. One is log ionized over 1 minus ionized, unionized is equal to pKa minus pH. Other is with the log. Log should be here, okay. Another is log base 10. 10 should be here. Okay, we can also shuffle it. We can also write in inverse. This inverse will be unionized divided by ionized is equal to 10 raised to power pH minus pKa. Remember, I have write this right side equation just like the acidic, because I have write this just like the acidic. But what I have changed? I have inversed the ionized and unionized formation. It means we have an idea, we can change these values, we can change the same scenario with the weakly acidic drug also. We have ionized over unionized is equal to 10 to the power pH minus pKa. But when we take the unionized divided by the ionized for the sake of weakly acidic drug, then 10 base power pKa minus pH. We can also write this. So I have written here for 5 times, 1, 2, 3, and this one is 4, 1. 4, this is the 5th one. 5 different ways to explain this equation, and answers of all the equations will be same. Because I have discussing these all different aspects, because we will see on the different books, and we'll see the different abbreviations where the writer can write in this way, also this way, the same, and also this way. Means they are not changing their right side values. They are taking the 10 raised to power pH minus pKa in case of weakly acidic and also weakly basic drug. But their left side values are changed. They are first divided with the unionized and 10 raised to power pH minus pKa, that is for weakly acidic. But when we change this denominator on the numerator and this denominator is on denominator, then 1 minus alpha or unionized divided by the ionized will equal to 10 raised to power pH minus pKa. In other way, 10 raised to power pKa minus pH. We should be very clear. So especially in this regard, there is the same scenario of the pH partition theory. Okay, come to the point. We are taking the example of quinine, which is weakly basic drug. And weakly basic drug and its pK value is 8.4. Do you remember the pH value of our blood? It's 7.4. So we can make the collaboration with this. For example, we are discussing weakly acidic drug, weakly basic drug, ionized divided by 1 minus ionized, 10 raised to power pKa minus pH. pKa of the drug is 8.4. pH of the blood is also, assume that it's equal, 8.4 and 8.4. Then what will be happen? Same just like this. Same pH, same pKa. Assume that 50% of drug is ionized and 50% of drug is unionized. For example, we assume that here is 10 raised to power 0, 8.4, 8.40. So 10 power, it's 1. Ionized, 1 minus ionized. Ionized is equal to 1 into 1 minus ionized, 1 plus ionized, okay, is equal to 1, 2, 1, and ionized is equal to 1 by 2 is 0.2, which is 50%. 50%. Now our sentence. If the drug is weakly basic, having the pK value equal to the pH value of the medium, then it assumes that 50% of drug is ionized form and 50% of drug is in unionized form. Clear? Okay. Next is another scenario. We have pK value 8.4, right? I will write the first formula here. This is the formula. Ionized 1 minus ion is equal to 10 power pKa minus pH. Remember, we are now getting difference with the weakly acidic drug. In this case, now pK is 8.4 of the quinine. pH of blood is 7.4. Now the difference is 1. Means the drug is present in that medium where the concentration of drug is, where the difference of the pH pK is 1, positive 1. So it means positive 1 means it's 10 raised to power 1, it's 10, and now it will be 10 minus 10a, and 11a is equal to 10, a is equal to 10 by 11. Answer is 0.91. Okay, it's 0.91 91. It's 91% ionized. Now we can make a table for here. Now we are taking the difference of 1 and we are assuming that it's 91% ionized and now it's 9% unionized. And 9% unionized means its minimum chance to be absorbed, to be penetrate from the blood towards the tissues. If we have the different pH value of the tissue, then we will assume that okay, it's present in the in ionized form in 91%. Sorry, 90%, and it's 10% is in unionized form. Okay, next scenario is we have the difference of the two. pK is 8.4 and now pH drug is present in that medium, for example in GI system, in duodenum. Its pH is 6.4, okay. Then the difference of these pK and pH is positive 2 and positive 2 is equal to 100 and this will be 100 A, okay, and this will be 101A and we will divide this 100 with the 101A. Okay, answer is 0.99. 99% drug is ionized form. So we can assume that if the drug is quinine is present in our GI system in duodenum where the pH is 6.8 and its pK is 6.4 and our pK of the quinine is 8.4. So the difference between the quinine and our duodenum is 2. We can assume that 99% drug is in ionized form and only 1% is unionized form. Okay, if we want to absorb this quinine by the transcellular, then its chance to be only 1% drug to be absorbed. And if we want to absorb by the paracellular through the ionization, then we can assume that 99% drug can be absorbed by the paracellular ways. Same case, we are now moving towards the negative way. For example, we have a pH, a pK value 8.4 and pKa is 8.4 and pH is 9.4. Now our difference is 1, but with negative -1. We can write ionized over 1 minus ionized is equal to 0.1. Why 0.1? Because 10 raised to the power -1. It's 0.1. Okay, we will solve it. Ionized 0.1, 1 minus ionized, 0.1 minus 0.1 ionized, and 1.1 ionized is equal to 0.1. 0.1 divided by 1.1 and ionized concentration is 0.09. Means 9% drug is now ionized. If we have a difference of pKa and pH, pH value is 1 unit higher than the pKa, or pKa is 1 unit lesser than the pH in the weakly acidic drug or weakly basic drug, we will get the 9% drug in ionized form. 91% drug is unionized form. So there is a chance to be absorbed of the drug of this quinine, where the pH of the drug is, pH of the medium is 9.4, may be absorbed by the transcellular maximum due to their unionization, due to their 91% unionization. So we can also a concept of this type of the absorption. Same case when we take the difference of 2. Okay, pK value of the drug is 8.4 and pH is 10.4. Then the difference is 2, but with the negative, -2. We will write here 10 to the power -2, that 10 to the power -2 will be 0.01 and this is 0.01, okay, this is 0.01 and 0.01. Now 1.01 divided by 0.01. Now at the end is 0.01 divided by 1.01 ionization. Okay, how much? Ionization is 0.009 or the 0.9% ionized. Maximum drug is in unionized form. Paracellular drug absorption might be possible. Okay, now we conclude it. What we have learned today, we have learned another concept of the diffusion. We are discussing the absorption of drug through the membrane. And for the sake of absorption of drug from the membrane, we are discussing with the concept of the passive diffusion. And this passive diffusion is due to the concentration gradient. And this passive diffusion can be divided into two different classes. The drugs which belongs to their absorption due to the unionization, where we will discuss the fixed first law, which is actually the explanation of the first order rate kinetics. And the other is the drugs which are moving towards their ionization. And when they are moving towards their ionization, we have the concept of the pH partition theory. In case of pH partition theory, we will divide these pH partition theory equations into two different, weakly acidic and weakly basic. In case of weakly acidic drug and weakly basic drug, the most important parameter which we have to know is pKa value of the drug and the pH value of our body. If we know the pH value of our body and also the pKa value of our drug, then we can calculate how much ionization of the drug is at the particular sites. We can check the ionization at oral cavity. We can check the ionization of the percentage of ionization in stomach and also the small intestine and then so on. So when we discuss the pKa and pH differences, we are assuming that, okay, if we have the same pH and pKa value of the weakly acidic drug, it is our clear concept, 50% of drug is ionized and 50% of drug is unionized. But when we are changing these values by increasing the pH difference with the, for example, here we have taken the difference of the pH with the pKa value, positive 1, then we get the 90% of the ionization and 10% unionization. Means if we want to move the drug through the ionization, then we have the plenty of concept here. Okay, in case of difference of the two, it's 99% ionized and 1% unionized, and the difference of the 1 but with the negative value, means difference is pH value is 1 unit lesser than the pKa value. Then we have the scenario totally inverse, 9% ionized and 91% unionized. And in case of difference of the 2 and pH value is 2 times lesser than the pKa value in weakly acidic drug, then it's 91.9% ionized and 99.1% ionized. And then we discuss the equations for the weakly basic drugs. And in case of weakly basic drug, the formula is same, but the difference is in the previous formula, in the case of weakly acidic drug, we subtract the values of pKa value from the pH. But in case of weakly basic drug, we subtract the pH values from the pKa. Formula will be ionized drug divided by unionized drug will be equal to 10 raised to power pKa minus pH. There which I take the example of the quinine and having the pKa value 8.4, and then we calculate their differences. If we take the same values of the pH and pKa, same scenario, 50% of the drug is ionized and 50% unionized, and same the cases with the having the difference of 1, 2 and then 3, then we can assume that, okay, there is the concept of the drug absorption through the ionization of the drug. Okay, I hope you understand this concept, and I assume that all of the students will take 2 examples of the weakly basic drugs also, and they will calculate their ionization and unionization states at pH 1.2, 4.5 and 6.8. Thank you very much. If you have any question, then you may contact me through my email or in the comments of this video. Thank you.